Let's go through LeetCode 1574, shortest subarray to be removed to make an array sorted. So it gives us an integer array and ask what is the shortest length of a subarray we can remove. So that after remove this kind of subarray, the rest part is non-decreasing. So we know brute force to do right this will be OM square time complexity, and we should do better because for the length for the array length to be 10 to the power fifth range. So what we're thinking about is that we look at this array, right? Trying to iterate from left to right, find the first one, which is violate the non-decreasing condition, or let's say this kind of I has smaller than previous one, right? Then we just put the index here, for example, u, right? That means for the part from index 0 to u, it is non-decreasing. And we can also do reverse part that we'll find from 2, 3, 5, that is non-decreasing part. So for our array, we have two parts, right? This part is non-decreasing. This part is also non-decreasing. And so we have a choice that for the first array, we don't select anything. So that means our result, there is one candidate is just delete from 0 to here. This is u, right? V from 0 to v minus 1, right? So we need to so that this kind of length that is v, right? Length v, and then what we do is that we try to go through the index of from I equals 0 and j equals v, right? So the thing is that if nums I is smaller than nums j, right? That means from nums I plus 1 to nums j minus 1, we are all be able to delete, right? So this will be one of the candidates. And also in this case, we can keep moving this kind of I index to get this delete length smaller, right? If nums I smaller equal to because it's non-decreasing. If it is greater than nums j, we have to move our nums j index, right? So that's in this case, we trying to see any all of those kind of cases we are able to delete to make it non-decreasing, right? And for our j, our end index, let's set to be n, so that when j is n, we can also move this kind of I index, right? So that we're not missing any case to delete the subarray. So let's write code for this. We're going to have int n equals array dot length, and we're going to have an u, which is the left part. What is the end index? Let's set it as 0 first, and v equals a minus 1. That is the right part, the start index. So what we do is while while u smaller than n minus 1, and nums u smaller equal to nums u plus 1. In this case, we can increase our u, right? So here, if U equals n minus 1, right? Means the whole array is non-decreasing. Then we don't need to delete anything. We just return 0. So, and also we'll write while v is greater or equal to 0. And in the array v minus 1 is smaller equal to array v, then we are able to have v decrease, right? Then we are going to have two pointers into I equals to 0, j equals to v, right? The thing is that we need to have a result initially set as v. That is, we only keep the right part, right? So we don't select any element from the first part. So that is one of, otherwise it will miss some kind of the first the one of the candidate, right? So and then what we do is that we'll write while this kind of I smaller equal to u and j smaller than n, right? So here I want to write j smaller equal to n because otherwise we because the thing that it's possible when j equals to n, j finished, the I is still iterate, right? Of course, if you write j smaller than n, just put the result as minimal v and n minus u minus 1, right? That is fine as well. But the thing is that if we don't want to miss any case that it's possible to delete, we can write this like j smaller equal to n. We write if j equals n or array I smaller equal to array j, then we are going to have a result equals max dot mean result j minus I minus 1, right? And we'll have I plus plus. In the other case that we just move the j pointer. In the end, we return result. In the Python code is very similar. Let's also write the Python code. N equals length array and u v equals 0 and n minus 1. So what I say while u is smaller than n minus 1 and array u is smaller equal to array u plus 1, we're going to have u increase by 1, right? And we'll say if u equals n minus 1, right, means the whole array is already sorted, then we don't need to remove anything. We can also write to find the right part while v is greater equal to 0 and array v minus 1 is smaller equal to array v, right? We're going to have v minus equal to 1. So then we're going to have I, j result equals 0 and v and v, right? So the first one is that we only keep the right part. So we don't select any element from the first part, right? So in that case, we also have a candidate v. array length v to delete, right? So we'll say, wow, I smaller equal to u and j smaller equal to n. So we'll say if j equals n or array I is smaller than array j. Uh, I read this one so that we don't miss any possible case to delete all of the subarrays. In this case, we are going to have result equals mean result j minus I minus 1, I plus equal to 1. Else, we'll have j plus move 1 index. In the end, we just return result. This is smaller equal to, right? It will be O(n) time complexity for these two pointers. And uh, actually, someone is writing for every index I, right? Because this kind of first part is already sorted. The real part is also sorted. For any subarrays, you can do the binary search, but it's not necessary. Binary search, this will be n and this log n, right? So use two pointer will be better approach.